This is Lecture 3, Describing Data. By the end of this lecture, you should be able to identify a variable's level of measurement, calculate a variable's measures of central tendencies, choose the best measure of central tendency to use when describing the most typical value of a variable, construct a frequency distribution, bar graph, and histogram, analyze frequency distributions, bar graphs, and histograms to describe a variable's distribution. In the last lecture, I discussed how to measure variables. In this lecture, I'm going to discuss how to use simple statistics to describe the average of a variable and its distribution. Recall that a variable quantifies a specific concept we are studying, such as war or voting behavior. Additionally, all variables have to have a unique name, and all variables take on numeric values and must have at least two values, such as 0 and 1. However, ideally, a variable should include more than two values in order to capture more information about what we are measuring. For example, in the previous lecture, we created a democracy variable that had two values, 0 non-democracies and 1 democracies. But we discussed how adding an additional category was important to deal with countries like Russia that are neither a democracy nor a dictatorship. In the first part of this lecture, I'm going to show you how to classify a variable based on the values the variable can take. You can classify a variable as nominal, ordinal, interval, or ratio level. Remembering the word noir is an easy way to remember these four terms, as the letters in the word noir are the first letters of these four words. Noir means black in French. Nominal level variables divide the subjects or observations in your variable into different categories. The categories are exhaustive, meaning that you include all the possible categories. The categories are also mutually exclusive, meaning that you can only place a subject or observation in your data set into one of the categories. And note, while there is a numerical difference in categories, there is no inherent order in the data. One category is not greater than another. For example, if you were collecting data on voters' party identification, you had to have three different categories in your data: Republican, Democrat, and Independent. These categories are mostly exhaustive as they capture the three main party identifications in the United States. These categories are also mutually exclusive because a voter cannot be classified into two categories, such as a Republican and a Democrat. And even though these categories have different numerical values, there is no inherent order in the variable. Even though independents are given a 2, they are not greater than Democrats, a 1, or Republicans, a 0. Ordinal level variables also divide the subjects or observations in your variable into different categories. The categories are exhaustive, meaning that you include all the possible categories. The categories are also mutually exclusive, meaning that you can only place a subject or observation in your data set into one of the categories. In addition, there is inherent order with an ordinal level variable. For example, many surveys ask respondents about the extent to which they support a candidate. The surveyors divide the support answers into numerical rank order categories, such as giving strongly oppose a -2, oppose a -1, neutral a 0, support a 1, and strongly support a 2. As you can see, the least support has the lowest value, -2, and as a respondent's support increases, the values go up by 1. However, note that while there is inherent numerical order in this data, the spaces between the categories are not inherently fixed. A survey respondent might feel that there is a huge difference between strongly oppose and oppose, but a small difference between oppose and neutral. Interval level variables are ordered. The spaces between the categories are fixed. For example, the spaces between 1 and 2 equal the same distance between 2 and 3, 1 unit. But with interval level variables, there is no true 0. Ideology could be an interval level variable. You could have a continuous ideology variable that range from 0, extremely liberal, to 5, moderate, to 10, extremely conservative. But the 0 in this case is an artificial 0. We could have moved the scale from -5 to 5 instead, and 0 would become moderate and would not fundamentally change the nature of the variable. Note that because interval level variables have no true 0, we cannot use ratios or percentages with them. Since there is no true 0, it is just an arbitrary marker. There is no 0 of something, so there can't be a percentage increase of something. To illustrate with the ideology variable, Since there is no true zero in the variable, there is no zero of something in the measurement, so there cannot be a percentage increase in something in the variable. Last, ratio level variables are ordered, the spaces between the categories are fixed, and ratio level variables have a true zero. Military spending is a ratio level variable. Military spending ranges from 0 to any positive value. And because there is a true zero, we can use ratios and percentages with the data. So for example, $2 of military spending is 100% more than $1 of military spending. Next, I'm going to show you how to use basic statistics to describe data. First, I will discuss measures of central tendency. Central tendency is just another way of saying the average or typical case of a variable. There are three measures of central tendency: the mode, median, and mean. The mode is the most common or most repeated value in the variable. In order to find the mode by hand, you arrange the values from the smallest to the largest, then you find the most repeated values in the data set. To demonstrate how to figure out which value of a variable has the largest number of observations, I will use Commonspace scores from the 106th Congress. Commonspace scores measure House members' ideological position by using roll call votes. Commonspace scores range from -1 to 1, with values less than 0 being liberal and values greater than 0 being conservative. In this particular example, I ordered the data from smallest to largest, and I found two modes. There is a mode for Democrats, -0.374, and a mode for Republicans, 0.359. In both cases, there are 6 observations with a value of -0.374 and 0.359. There are no values in the data set where 7 or more observations share the same value. The second measure of central tendency is the median. The median is the middlemost value of a variable. It cuts the variable in half with the lowest 50% of values on one side and the highest 50% of values on the upper side. To find the median by hand, you arrange your variable from the smallest to largest value. Then you find the median observation number. The position of the median when you have an odd number of observations is equal to the number of observations plus 1 and that value divided by 2. In our Commonspace score example, there were 437 observations. 437 plus 1 is 438. 438 divided by 2 is 219. The median observation number is 219. I have arranged the data from the smallest to the largest value. Observation 219 has a value of 0.137. So the median is 0.137. If the median House member has a Commonspace score of 0.137, who do you think controlled the House of Representatives, Republicans or Democrats? It was Republicans. Recall that the Commonspace scores greater than 0 indicate a House member is conservative. The median tells us in this case that the average House member is conservative, indicating that Republicans control the House of Representatives. I showed you how to find the median for a variable with an odd number of observations. Now I'm going to show you how to find the median for a variable with an even number of observations. With an even number, the position of the median calculation will produce a number that will have a 0.5 as a decimal at the end. The median is the average of the values for observations below and above the position of the median number. So let's say we have a Commonspace variable with 436 observations. We would run the same calculation as before. The position of the median when you have an odd number of observations is equal to the number of observations plus 1 and that value divided by 2. We get a number with a 0.5 at the end. So what we do is we take the observation that is below this value and the observation that is above this value and find the average of those two observations. If we have 436 observations, our calculation would produce 218.5. So we should take the average of observations 218 and 219. Observation 218 had a value of 0.135. Observation 219 had a value of 0.137. The average of 0.135 and 0.137 is the sum of those two numbers divided by 2, or 0.136. The third measure of central tendency is the mean. The mean is the sum of a set of values divided by the total number of observations. Formally, the equation looks like this. X bar means the mean of X. Any variable name with a bar over it indicates that it is the mean of that variable. The Greek letter sigma, capitalized, means the sum of. In this case, it means the sum of all the observations in X. And n means the number of observations. For our Commonspace score example, the mean of the Commonspace scores, or the sum of the Commonspace scores, divided by the total number of observations. I calculated this by hand. The sum of the Commonspace scores was 21.788. The total number of observations was 437. 21.788 divided by 437 equals 0.05. The mean of the Commonspace scores was 0.05. So, in sum, there are three different measures of central tendency, the mode, median, and mean. And all three measures give us different values, as in the Commonspace score example, leading us to draw different conclusions about the average or typical case of a variable. So when do we use these three different measures? If we are examining a nominal level variable, we should only use the mode. Recall that the values of a nominal level variable have no order. The mode does not assume a variable has order, but the median and mean do assume a variable has order. Hence, with the nominal level variable, we only use the mode to describe the typical case of the variable. With an ordinal level variable, the values of the variable have order, but the spaces between values are not fixed. We can use the mode for an ordinal level variable because the mode simply tells us the most common value in the data. We can also use the median because we can order the data from smallest to largest and find the middlemost value. We can also use the mean, but it is debatable whether it makes sense to use the mean for an ordinal level variable. The mean assumes that the spaces between the values of a variable are fixed, which is not always the case with an ordinal level variable. Nevertheless, social scientists often use the mean to describe an ordinal level variable. Next, recall that interval and ratio level variables are ordered and continuous. Hence, we could either use the mean, median, or mode to describe the typical value of these types of variables. Back to the Commonspace scores example. Recall that Commonspace scores are ordered and continuous. They do not have a true zero, so Commonspace scores are interval level. Hence, we can use the mode, median, or mean to describe this variable. However, the mode, median, and mean tells us different things about the typical value of the variable. According to the modes, the typical members of the house are either liberal, with a score of negative 0.374, or conservative with a score of 0.359. According to the median, the typical member is moderately conservative with a score of 0.137. And according to the mean, the typical member is moderate with the value of 0.05. So which one is correct? It depends. We really cannot make an informed judgment about which one of these to use until we examine how the values of the variable are distributed in a bar graph or histogram. In the next couple of sections, I'm going to show you how to create frequency distributions, bar graphs, and histograms. Then I'm going to show you how to use them to help you decide which measure of central tendency to use to describe a variable. While measures of central tendency tell us a typical case of a variable, frequency distributions, bar graphs, and histograms tell us whether most observations of a variable have values that are close to the mean, median, or mode, or spread out away from the mean, median, or mode. A frequency distribution is a table that summarizes the distribution of a variable's values. It tells us how many observations each value take. It is mostly used for analyzing the distributions of nominal and ordinal level variables. As an example on how to build a frequency distribution, I will use hypothetical POLID4 data. POLID4 measures the openness of democratic institutions. POLID4 classifies countries as autocratic, onocratic, or democratic. This is a hypothetical dataset of 10 countries. Each country's POLID4 classification is indicated in the column here. As you can see, there are 3 democracies, there are 5 unocracies, and there are 2 autocracies. We will use this information to build a frequency distribution. Here is the frequency distribution. In the first column, you write categories as the column title. Then you write the categories underneath it and add the word total to the bottom. The categories should be written in some sort of logical order if possible. In the second column, you write F as the column title. Then you write the number of observations in each category and add the total number of observations at the bottom. Here's the frequency distribution example with the polity data. In the first column, you write categories as the column title, then you write the categories underneath it, autocracy, anocracy, and democracy, and add the word total at the bottom. The categories should be written in some sort of logical order, so in this case I wrote the categories from the least free countries, autocracies, to the most free countries, democracies. In the second column, you write the letter F as the column title, then you write the number of observations in each category and add the total number of observations at the bottom. As you can see, there are 2 autocracies, 5 anocracies, and 3 democracies, for a total of 10 observations, which you write at the bottom here. You can also add 2 additional columns to your frequency distribution. The first is the category percentage column. It tells you the percentage of cases each category takes in the data set. It is calculated by dividing the total number of observations in one category by the total number of observations overall and multiplying that value by 100. Going back to our frequency distribution example, the category percentage for autocracy would be 2 divided by 10 and that number multiplied by 100, which is 20%. The category percentage for anocracy would be 5 divided by 10 and that number multiplied by 100, or 50%. And the category percentage for democracy would be 3 divided by 10 and that number times 100, or 30%. Here we add a column with the category percentage title, and then we add 20%, 50%, and 30% to the appropriate rows. All of these values should add up to 100%. The last column we add to the frequency distribution is the cumulative percentage. The cumulative percentage tells us the percentage of observations at and below a given value. Note this assumes there is order in the data, so this is mostly for ordinal, interval, and ratio level variables. So the cumulative percentage for a category is the sum of category percentage for that category and all the category percentages in the categories below it. So for example, the autocracy category is the first category, so it only has a cumulative percentage of its own category, 20%. The cumulative percentage value for anocracies would be the sum of the category percentage for anocracies and autocracies. So it would be 20% plus 50%, which is 70%. The cumulative percentage value for democracies would be the sum of the category percentages for autocracies, anocracies, and democracies. So it would be 20% plus 50% plus 30%, which equals 100%. We add this information to the last column. You write cumulative percentage as the column title and add 20%, 70%, and 100% to the appropriate rows. Note that we leave the total row empty for the cumulative percentage column. Now I'm going to show you how to interpret a frequency distribution. The information in the category percentages column can tell you the percentage of observations within the variable that fit within each category. So for example, the autocracies category percentage was 20%. We can say that 20% of our observations were autocracies. You can also add the category percentages together to get the total percentage of observations in more than one category. So for example, you can add the anocracy and democracy categories together, category percentages together, to see how many observations lie within the anocracy or democracy categories. To do this, you would add 50% and 30% together to get 80%. So 80% of our observations in our variable are either anocracies or democracies. Because the category percentage column tells you the percentage of observations within the variable that fit within each category, you can use the category percentage column to find the mode of a variable. The mode is just the category with the highest category percentage in the table. So for example, anocracy has a 50% percentage category or category percentage, which is the highest value in the category percentage column. So anocracy is the mode for this variable. It is the most common category among the observations. Next, the cumulative percentage column tells us the percentage of observations at and below a given value. So for example, the anocracy cumulative percentage tells us that 70% of observations in the variable are either anocracies or autocracies. Next, with the cumulative percentage column, you can also identify the median of the median value of your data. Recall that the median is the middlemost value of a variable when the variable is ordered from smallest to largest value, with 50% of observations above the median and 50% of observations below the median. To find the median in a frequency distribution table, all you have to do is find the cumulative percentage category that encompasses the middlemost observation, or the observation at 50%. Autocracy only goes up to 20% in the cumulative percentage column, so autocracy cannot be the median. Anocracy goes up to 70%, so it includes the 50% value. So anocracy is the median value of this data set. Last, the cumulative percentage column can also help you identify the top percentage of cases of a variable. So for example, you may want to identify the top 79% most free countries in the world. To do this, you start at the democracy category, since the democracy category indicates the most free countries in the world. The democracy category has a cumulative percentage of 100%. You subtract 79, the topmost value, from 100% and get 21%. 21% will be the bottom value. Then you find the categories within the cumulative percentage column that range from 21% to 100%. These are the observations with the countries that are the top 79% most free countries in the world. The anocracies and democracies categories hold the cumulative percentage observations between 21% and 100%. Hence, anocracies and democracies are the most free countries in the world.
In the next part of the lecture, I will show you how to make a bar graph. A bar graph is a visual representation of the data from a frequency distribution. As such, it is best used for nominal and ordinal level variables. When you construct a bar graph, you place the total number of cases, or percent of cases, on the y-axis and the category names on the x-axis. Then you add bars on the top of the categories on the x-axis to represent how many observations fit within each category. This is a bar graph that represents the information from the Polity 4 frequency distribution example. As you can see, the percent of cases is on the y-axis. The category names are on the x-axis. Note that I placed the variable name below the x-axis as well. %% of the cases were autocracies. So, in the bar graph, I made it so that the bar went to 20 above autocracy. Similarly, there were 50% of cases that were anocracies and 30 that were democracies. So I put the bar above anocracy to 50 and the bar above democracy to 30. To interpret this bar graph, we could say 20% of the cases were autocracies, 50% were anocracies, and 30% were democracies. Now I'm going to briefly describe how histograms are constructed. A histogram is just a special kind of bar graph for interval and ratio level variables. If we made a bar graph out of an interval or ratio level variable, then we'd have to put a category on the x-axis for every single value of the variable, which would be a lot of categories. With so many categories on the x-axis, the graph wouldn't be visually appealing or informative. So instead, we create categories or bins on the x-axis that represent a range of values for the variable. And then we count to see how many observations have values that fit within the range of those values for each category. Hence, the bars represent the total number of or percentage of observations in the variable that fit within the range of values for each category. Here is an example of a histogram of Commonspace scores from the House in the 106th Congress. Recall from the beginning of the lecture that Commonspace scores measure Congress members' ideological leanings on a -1-to-1 scale based on their voting behavior. As you can see on the x-axis, these bars do not represent specific values in the variable. They represent ranges of values. This makes the graph more informative and visually appealing. If there was a bar for each Commonspace value, the graph would be very cluttered, messy, and hard to interpret. So what does this histogram tell us about the typical member of Congress? We could say something like, there was not one typical House member in the 106th Congress. Instead, there were two typical House members in the Congress, a liberal Democrat here and a conservative Republican about here. Democrats and Republicans in Congress have different ideological preferences based on their voting behavior. Now I'm going to show you how to describe a bar graph or histogram for ordinal, interval, and ratio level variables using the following characteristics: center and spread, number of peaks or modes, and skewness. The center of a bar graph or histogram is where the median is located. You can calculate this by hand or use SPSS to do it, which you will learn how to do in the next lab video. The simplest way to calculate the spread of a bar graph or histogram is to take the value of the largest observation value and subtract the value of the smallest observation value from it. For example, in this bar graph, the center or median is 50. The spread is 90, the largest value, minus 10, the smallest value, which is 80. The next characteristic of a bar graph or histogram that you should describe is the number of peaks and where they are. A peak is like a mountain peak. It creates a clear upward pattern in the data with other bars following that pattern and eventually clustering around it. To find a peak, draw a general outline on top of the bar or histogram. On top of the bar graph or histogram. Here is a histogram of states' vote share for Gore in the 2000 presidential election. I drew a general outline on top of it. From this outline, I can see that there is one clear peak around 45. There's an upward trend to this peak that the other bars follow, and these bars are all clustering around the peak. Here is a histogram of the Heritage Foundation's ratings of government spending. I drew a general outline on top of it. From this outline, I can see that there is one clear peak around 80. There is this upward trend to this peak that the other bars follow. It is like the bars are building stairs up here to the peak. and these bars are clustered around the peak. Here's a histogram of the UN's Gender Inequality Index for countries around the world. I drew a general outline around it. From this outline, I can see that there are two clear peaks, one around 0.3 and one around 0.7. There are two distinctive upward trends with the bars clustered around them, a smaller one around 0.3 and a larger one of around 0.7. With this graph here, the upward trend to the one peak looks like stairs. There's no other distinctive peak in this graph. With this graph here, the two upward trends look like two very different distinctive mountain peaks with bars clustered around both. Now, when you describe the peaks in a graph, you should note how many there are and where they are. If there's only one clear peak, the graph is unimodal. If there are two clear peaks, the graph is bimodal. If there are many clear peaks, the graph is multimodal. And if there is more than one clear peak, note if the peaks are about the same size or if some are bigger than others. Also note, as this is a bit confusing, that calculating the mode or peaks by hand is different than identifying the modes or peaks in a graph. Here is an example of a graph that is unimodal with one mode or peak at 50. This is one clear peak. Here is an example of a bar graph that is bimodal with one mode at 0 and the other mode at 100. These are two distinct peaks. Note that the peaks are about the same size. Here is an example of a bar graph that is bimodal with one mode at 0 and the other at 100. The 0 mode is larger. The next characteristic of a bar graph or histogram that you have to describe is skewness. If a bar graph or histogram has a negative skew, the left side of the graph extends much further than the right side of the graph. If it has a positive skew, the right side of the graph extends much further than the left side of the graph. If there is no skew, the left and right sides of the graph extend about the same amount from the center of the graph. You could fold it in half and the shapes would be the same on both sides. This is an example of a bar graph with a negative skew, as the left side of the graph extends much further than the right side of the graph. Here is a drawing I made on the top. As you can see, the left side is extending much further than the right side. It is extending into a negative direction, hence a negative skew. Here is an example of a bar graph with a positive skew, as the right side of the graph extends much further than the left side of the graph. Here's a line that I drew on top of the graph. As you can see, the right side is extending much further than the left side. It is extending into a positive direction, hence a positive skew. And this is an example of a bar graph with no skew, as the left and right sides of the graph extend about the same amount from the center of the graph. You could fold this distribution in half, and the left and right sides would be about the same shape.
In the next slides, I'm going to give you examples of how to use center, spread, modality, and skewness to describe bar graphs and histograms. In this graph, the center is 50, which I calculated by hand, but you could use SPSS to do it. The spread is 90, the largest value, minus 10, the smallest value, which equals 80. The graph is unimodal with one mode at 50, and there is no skew as the left and right sides of the graph extend about the same amount from the center of the graph. In this graph, the center is 50, the spread is 100, the largest value, minus 0, the smallest value, which equals 100. The graph is bimodal, with one mode at 0 and one mode at 100. The peaks are even, and there is no skew as the left and right sides of the graph extend about the same amount from the center of the graph. In this graph, the center is 50, the spread is 100, the largest value, minus 0, the smallest value, which equals 100. The graph is bimodal, with one mode at 0 and the other mode at 100. The peaks are not even. The 0 peak is larger than the larger mode, and there's no skew as the left and right sides of the graph extend about the same amount from the center of the graph. In this graph, the center is 50, the spread is 70, the largest value, minus negative 10, the smallest value, which equals 80. The graph is unimodal with one mode at 50. In this graph, there is a negative skew as the left side of the graph extends much further than the right side of the graph. In this graph, the center is 20, the spread is 70, the largest value, minus 10, the smallest value, which equals 60. The graph is unimodal with one mode at 10. In this graph, there is a positive skew as the right side of the graph extends much further than the left side of the graph. In this section, I will summarize how to use everything you've learned in this lecture to describe variables. You can use this metacognition card to help you decide how to describe your variables. If you have a variable that is nominal level, you can only use the mode as a measure of central tendency. And you interpret the bar graph. And as you interpret the bar graph, you can only discuss the percentages for each category. For example, you can only say that a specific percentage of observations fit within the first category of the variable. If you have a variable that is ordinal level, you should use the mode or median as a measure of central tendency, but you can use the mean. If you have a variable that is interval or ratio level, you could either use the mode, median, or mean as a measure of central tendency. For ordinal and interval and ratio level variables, you should use center, spread, number of peaks, and skewness to describe bar graphs and histograms. And then your description of the graph can tell you which measure of central tendency or measures of central tendency are the best to use to describe your variable. If the graph is unimodal with no skew, use the mode, median, or mean, as they are all fine to use because they will likely have similar values. If the graph is bimodal or multimodal, use the modes from the graph. If the graph has negative or positive skew, use the mode and the median. The reason we use the mode and the median is because the mode tells us the value of the variable most observations are clustered around, and the median tells us where the middle of the distribution is. The mean is not useful because the skewness of the distribution either pulls it too far in a negative or positive direction, and this would misrepresent the typical case of the variable. I will use the Commonspace scores example from the beginning of the lecture to show you how to use the metacognition card to figure out how to describe a variable. Recall that Commonspace scores measure Congress members' ideological scores. They range from -1, very liberal, to 1, very conservative. As such, they are ordered and continuous, but they don't have a true zero, so Commonspace scores are interval level. Hence, we can use the mode, median, or mean to describe this variable. However, the mode, median, and mean tell us different things about the typical value of this variable. According to the modes, the typical member of the House are either liberal with a score of -0.374 or conservative with a score of 0.359. According to the median, the typical member is moderately conservative with a score of 0.137, and according to the mean, the typical member is moderate with a value of 0.05. So which one is correct? If we look at the distribution of the Commonspace scores, it is clear which one we should use. Here's the histogram of the Commonspace scores. The center is 0.137. The spread is 1.75. There are two peaks, so it is bimodal. One peak is around -0.374. One peak is around 0.359. The 0.359 peak is larger, which means there are more typical conservatives than liberals. There is no skew. Going back to the metacognition card, since the graph is bimodal, we should use the modes from the graph. So we can conclude the Commonspace scores demonstrate there are two typical types of Congress members. One type is liberal, the other is conservative. There are more typical conservatives than liberals since the 0.359 peak is larger. There are very few moderates in Congress.